Right circular cones are just one type due to the angle and base of the cone. Learn about them here in Mathematics of Engineering. Cones are similar to pyramids, only with specific base in the shape of circles or ellipses. Thus, the type circular cones. The description of right means the axis of the cone makes a right angle to the plane of the base, which means the altitude is perpendicular to the radius. If we cut open the cone, a sector is created. Let's correlate the two figures. The slant height of the cone is actually the radius of the sector. Moreover, the circumference of the circular base is the arc of the sector. So we can generate arc S as 2 pi r, where r is the radius of the base of the cone. Let's solve for the areas and volume of given right circular cones, just like shown in the figure. The radius is 3 cm and the slant height is 7.6 centimeters. First, we take the lateral area, which is basically area of the sector, with radius of 7.6 cm and arc of 2 pi r. This is 2 pi times 3, which is 6 pi. With the arc equation, S is equal to r theta, place the given value 6 pi as equal to 7.6 theta. So theta is then taken as 6 pi all over 7.6, which is then solved as 2.48. Learning the radius and central angle of the sector, we can use ratio and proportion to solve for the area of the sector. We have the area of the sector is to 2.48 as pi times the square of 7.6 all over 2 pi, where a sub s becomes 114 over 5 pi, or 71.63 square centimeters. Thus, the lateral area of the cone is 71.63 square cm. Next is to take the surface area, which is solved as the lateral area and the area of the base. Having determined the lateral area, we move to solve the area of the base from pi r squared, or that is pi times 3 squared. The area of the base is then 9 pi. The surface area of the cone is then 114 over 5 pi plus 9 pi, which is solved as 159 over 5 pi, or 99.9 square cm. Last is the volume, which is solved through a third of the area of the base times the altitude. But we still need to look for the altitude, so draw a triangle from the slant height, axis, and the radius of the base of the cone. By using Pythagorean theorem, the altitude is the root of 7.6 squared minus 3 squared, which results to 6.98 cm. The volume is then a third of 9 pi times 6.98, which is simplified as 65.81 cubic centimeters. For the second example, the diameter of the base is 14 kilometers, and the slant height of the cone is 15.7 km. With d as 14 km, the radius is half, which gives 7 kilometers. Cursive L is 15.7 km. For the lateral area, which is the area of the sector, the radius is 15.7 km and the arc is computed from 2 pi r, which is 2 pi times 7. So S is 14 pi. With S as equal to r theta, place the given parameters to have 14 pi as equal to 15.7 theta. So theta is taken as 14 pi over 15.7, which is then simplified as 2.8. Through ratio and proportion, we plug A sub S is to 2.8 as equal to pi times 15.7 squared is to 2 pi. So the area of the sector is 345.086 square kilometers. Thus, the lateral area is 345.086 square kilometers. The next task is to solve for the surface area, which is through the lateral area plus the area of the base. We just solve for the lateral area, and the area of the base is taken as pi r squared, which is pi times 7 squared, giving 49 pi. With the base area already determined, the surface area is then 345.086 plus 49 pi, which is then 499.02 square km. The volume, on the other hand, is solved as a third of the area of the base times the altitude. The altitude is generated from the right triangle comprising the axis, slant height, and the radius of the base. The altitude is then the root of the squares of 15.7 minus 7, which becomes 14.05 km. Thus, the volume of the cone is a third of 49 pi times 14.05, which becomes 720.941 cubic kilometers. The next variation of solving areas and volumes through a given figure is when a diameter of the base is again given, but instead of the slant height, the altitude of the axis is provided. This is then 18 cm, so the radius is half of 18, which is 9 centimeters. The altitude A is also given as 18 cm. Having the altitude, we can start off with the volume of the cone, as we have to compute a third of the area of the base times the altitude. The area of the base is pi r squared, and that is taken as pi times 9 squared, which turns out as 81 pi. The volume of the cone is then a third of 81 pi times 18, which results to 486 pi cubic centimeters. Now, let's solve for the slant height of the cone by using the right triangle as shown. Through Pythagorean theorem, the slant height is then the root of 18 squared plus 9 squared. So the slant height is computed as 9 root of 5 cm. The sector can then be drawn with radius of the slant height 9 root of 5, and the arc is 2 pi r, which is 2 pi times 9, and that gives 18 pi. The key to solving the areas of the cone is through the sector. With S as r theta, we have 18 pi as equal to 9 root of 5 times theta. Theta is then 18 pi all over 9 root of 5, giving 2.81. Using ratio and proportion for the area of the sector, we have A sub S is to 2.81 as equal to pi times the square of 9 root of 5 is to 2 pi. The area of the sector, which is also the lateral area, is 569.025 square centimeters. The surface area is also solved as the lateral area and the area of the base, which are replaced as 569.025 plus 81 pi. The surface area is then 823.49 square centimeters.